In my last video, I took 10 shots at this trash can and we tried to find the probability that I would make 7 or more of them. But what if I don't care about the probability of making a certain number of trials? What if instead I want to know the probability that the first time I make it will be on my first attempt? Or what's the probability that the first time I make it will be on my 5th attempt? Or what's the probability that if I flip this coin, the first time I do it, I'll get a heads? Or even if I roll this die, the first time I get a 6 will be on my 3rd roll. All of these questions fall under the idea of geometric probability distribution. And that's what we're going to be talking about today. Hey guys, and welcome back. My name is MrCaproni, and this is Probability and Statistics. Today we're going to be talking about geometric distributions. Now remember, this is part of a 3-video series where we covered binomial distributions, today's geometric distributions, and the next one will be Poisson distributions. Now these are all probability distributions, and it's all about finding the probability of a specific type of situation that otherwise would be very difficult to find. Today, geometric distributions is all about the idea of the first. It's not about counting the number of successes. It's about counting the number of trials until you get your first success. So it's something like the probability that my 5th attempt will be the first success, or that the first success may occur in the first 3 attempts, or the 10th attempt or later. These are all geometric distribution ideas, and that's what we're going to cover today. So let's go ahead and dive right into that material. First and foremost, what makes a geometric distribution so geometric? Well, I got 4 things we're going to look at that classify a situation as being a geometric distribution. And the first one is that you're going to do trials over and over again until your first success. So this means that this is any situation where we have some type of thing that we're doing and we can either succeed or fail. And we're going to do that thing over and over and over again until our first success. That could happen right away, or it could happen way down the line. Regardless, we're going to stop doing the trials the moment we get our first success, which brings us to our second item that makes it geometric, which is that each one of these trials are independent of each other, meaning that no matter what happens the first time I do it or the second time, it's not going to change the outcome of the next one. And it's not even going to change my probabilities there, which brings us to the third one, that the probability of success has to be the same every time you do it. So it can't be like, oh, I missed this time, so now I have a better chance of making it next time. Or now that I have done it over and over and over again, my probability of success is going up. That changes the situation each time. So when you're dealing with a geometric distribution, you actually need the probability of success to stay the same every time you do it. And lastly, this random variable that we're counting, the x, is not like it was for binomial distribution. In binomial, we had a set number of trials and we were trying to find out how many successes we had, even if that were 0. But in this case, we're not counting how many successes. We're counting the number of attempts that it takes us until we get that first success. So if I miss 4 times, then make it on the 5th one, well, then we're looking at 5 attempts until my first success. That's the x variable here, not the number of trials that were successful. It's the number of attempts until we were successful. Sweet. So now that we actually know what a geometric distribution is, we can go ahead and talk about what we're actually finding the probability of. So in this case, when we're dealing with these geometric probability distributions, we're looking at the number of attempts until our first success. So that means I want to find the probability that the first heads I'm going to flip is going to be my 3rd flip. So in other words, I want to know the exact probability that I would get a fail, and then a heads. Or I want to know the exact probability that I would miss my first 4 shots before making the 5th one. In that case, x would be 5, which brings us to our first thing, the important notation that goes along with a geometric distribution. And we're going to have the first one as P, the probability of success for your single trial. So when we get to the point of using a formula, P is always going to represent our probability of success, while Q will always represent our probability of failure. Now, when you're plugging this into a formula, remember, we always want that in decimal form. That way we get the correct numbers in the end. You don't want to leave it as a percent, or really a fraction would be all right, but decimal is usually the best way to go here when plugging it in. And the last thing we need in terms of notation is that X that I have mentioned over and over again. That's the actual number of trials until I want to know the first success. So that would just be like, hey, if I say 6, I'm going to have 5 failures, and then the 6th one is a success. What's the probability of that situation happening where I get the 5 failures and the 6th one is success? That's the probability we're actually finding here. So let's go ahead and dive into the actual formula we're going to use for this. So here's the formula for the geometric distribution. It's your probability of success times your probability of failure raised to the x minus 1, where x is the number of attempts until your first success in the given situation. Now, this shouldn't be surprising to us because it's actually a direct result from the multiplication rule, which we covered way earlier in one of my other videos. So what did the multiplication rule say? Well, it actually said that you can take the probability of each situation and multiply them together to find the probability that all of those situations would happen together. So in this case, that's exactly what we're looking at. Let's say I want to spin a spinner that has 4 colors on there, and I want to know the probability that the 4th spin will be the first time that I land on blue. Well, guess what? For the first time I spin that spinner, I'm hoping to get a miss, not a blue. So that means that there is a 75% chance of that happening because there are 3 other ones out of the 4. It gives us a 75% chance of failure. Then if I spin again, I want the second one to also be a fail, the third one to be a fail, and then finally the 4th one would be my success. And the multiplication rule tells me that if I wanted to find this probability, I would do 0.75 times 0.75 times 0.75 times 0.25, and that would give me the answer. Well, that's what this actual formula says. Look, P is the probability of success, that would be the 0.25, and Q is the probability of failure. And because in this case my X was 4, 4 minus 1 and that exponent up there gives us 3, so I should have 3 of the 0.75s being multiplied together. That's the formula, guys. It's really just an extended use of the multiplication rule. I know what you're thinking. Mr. Caproni, let's take it back to you shooting that paper ball. I want to know the probability that the first shot you make is the first attempt you take at it. Well, that's a little bit boring of a problem, but we're going to do it anyway just so you can kind of see how this all works. In this case, remember, I went ahead and took 50 shots and I made 41 of them and missed 9. So that's what we're going to use as our probability of success and failure. And in this case, the number of attempts would just be 1 because I want to know the chance that I would make it on my first attempt. Now, we don't want to leave it as 41 over 50 or 9 over 50 because we said decimal form was probably best. So if you go ahead and plug those into a calculator, you can find out very easily the decimal form being 0.82 and 0.18. So then we need to jump to our actual equation. And we can go ahead and plug the numbers in there. Now, notice the exponent here is going to be kind of where we get a little sticky because 1 minus 1 is just 0. And you need to remember the rule that if anything is raised to the 0th power, then it's just equal to 1. And 1 times anything is just whatever that thing is. So really the answer to this question is just 0.82. Well, duh, what's the probability of success on each attempt? Well, it's 0.82. So what's the probability that I would make it on my first attempt shooting? 0.82, or an 82% chance of success. So let's mix this up a bit to get a little bit more into the weeds of doing a geometric. We're going to try seeing the probability of success on the second shot being the first success. In other words, I missed the first one, but then make the second one. Well, in that case, I plug in the numbers all the same. And this time when we subtract in the exponent, we just end up with 1, which means ultimately I'm just doing 0.82 times 0.18, which gives me 0.1476 or 14.76%. So that means that there is a 14.76% chance that the first shot I would make would be the second shot. Now, you can alter this problem as many ways as you want. For example, I could say, what's the probability that I would make it in the first 3 shots? Well, then I would find the probability of x being 1, find the probability with x being 2, and find the probability with x being 3, add those 3 probabilities together, and it would give you the probability that I would make my first shot in any of the first 3 attempts. And that will never go over 100% because we know this is a probability distribution, which means if we add them all up, they should add to 100%. So there's no way you'll ever go over that 100% mark. It goes the same way as if I said I wanted to know the probability that I wouldn't make it until my 10th attempt or later. Well, then in that case, I could go ahead and find the probability where X is 10, 11, 12, 13, 14, all the way on forever. And in that case, it might be a little bit better to start using some technology because I'm not going to keep doing this formula over and over and over. And voila, that is the geometric distribution. So essentially, at the end of the day, what we're doing is just multiplying that probability of failure over and over and over until you get your first success where you multiply by your p. And remember, guys, our next video on this section is going to be on Poisson distribution. So stick around for that. Now, if this video was helpful at all, make sure you remember to go ahead and hit that like button. And if you want to keep getting videos like this one, then go ahead and click subscribe as well. Remember, my name is MrCaproni, and this has been Probability and Statistics. I hope you have a fantastic day.